2024 question 3 was an angular velocity question leading to this diagram, and we're asked for the forces acting on A and to show that angular velocity is equal to this expression with tan in it. So the forces acting on A here, we have it's 3.5 away from the center, so we're going to need to add that on when we're looking at the radius. Will be 3.5 plus this distance here, which we'll be able to get in terms of A. Okay, so fixed point X, we have a string, we have our seat, we have tension in the string, we have my angle alpha, I'll just use a capital A, we have mg coming down, we also have A inside this triangle here if we need it, with my right angle. So we have mg cos A, and in this direction we would have mg sin A. We're also told that it's 4.3 long, so this is 4.3 up here, this one here is going to be 4.3 sin A. That's what we need in here, that's this one here, so that gives us the radius will be 3.5 plus 4.3 sin A. And we also know that this t sin A in here, we draw that triangle again, we're going to have tension A, and we're going to have t sin A, that's directed towards the center. So my angular velocity will be equal to t sin A, so which is mw squared, or mw squared, or my force acting towards the center will be equal to t sin A. I think that's the starting point here. Let's see what they're looking for down below. We need to get tan in here, so we're going to need sine over cos to get tan. So let's see what else we have. Well, we have or, which we can substitute in here. In terms of mg, which is in the question, we're going to have mg will have to be equal to this side here in terms of tension, so that's t cos A. So mg is equal to t cos A. We can see here the equivalence. So that would, the tension in the string will be mg over cos A. That might give us the sine over cos part. So we have tension in the string. So we have mw squared by 3.5 plus 4, that should be 0.3 sin A is equal to t sin A. So that's equal to mg cos A, mg over cos A by sin A. That gives me the tan they're looking for, so we're going to can't divide by m and divide, so we're going to get w squared is equal to tan A, sine over cos, and there's a g before it, divided by 3.5 plus 4.3 sin A. So omega will be the square root of g tan A over 3.5 plus 4.3 sin A. Is this what they're looking for? G tan A? It is the same expression. Okay, dimensional analysis for this expression. When we have g on top, g is ms to the minus 2. On the bottom, we just have a constant and a constant. So that's just distance, so that's m. And angular velocity is radians per second. So that's 1 over s. And in this case, we have the square root of this expression. And the m's will cancel each other out, and we'll end up with the square root of 1 over s squared, which is also equal to 1 over s. So 1 over s equals 1 over s. That's my dimensional analysis. alpha's 25. How many complete revolutions will it make? Okay, we'll get it in seconds if we can get W. So W is equal to this expression, so the square root of g tan 25. So 9.8 tan 25 divided by 3.5 plus 4.3 sine 25. That's going to give 0.92705. So that's radians. That's my angular velocity, so we need to divide 2 pi by W to get how long it will take to do a revolution. So that will be 2 pi divided by 0.92705 will give one revolution in 6.7776 seconds for one. So in 60 seconds, how many will we get? It's just going to be less than 10. 6.7776. That's 1 minute. And that's going to give me 8.85. What does it ask for? How many complete revolutions? So 8 complete. And then a person sitting on seat A throws a small orange in the air. The person imparts an upward vertical velocity of 4 meters per second. Calculate the time from when the orange is thrown to when it hits the ground. So if we are sitting here, we're 6 meters above ground. If we throw it up, it's going to go up and stop. And then it's going to come back down. So we could get the distance, the time taken to get up to here, and then we could get the time taken to get to the bottom and add them together. But the easiest way is to just use displacements formula. We know that gravity is going to slow it down. So how long to go 6 meters with an initial velocity of 4, and gravity divided by 2 times t squared. If we solve this for t, I did it this way first just to check what we got, and then this works out to be exactly the same. Doing it this way, you'll get, it takes 20 over 49 will be the time taken to get to this point where it stops, and then the distance traveled in that time is 40 over 49, and so on. You can work your way down. Now we have to go 6, that plus 6 is the distance down to the bottom, and you'll get the same answer as if you do it this way, which is a bit quicker. Time will take 1.59 seconds to get to the bottom.